today's lecture we are going to talk about binomial expansion. Now, in binomial expansion, there is something you have to understand, and the reason why binomial expansion is coming from is because when we have a term of such x plus y and the power is kind of big, we have bigger power. And we can't just keep expanding and expanding. If we expand this thing, this will take a whole lot of time. But because of that, that is why binomial expansion will be used. So binomial expansion helps us to expand very fast using Pascal triangle. So let's assume we are about to expand this. Let's assume we're about to expand this. Let's assume we're about to expand this in a normal way. Of course, this is 1, 2, 3, 4, 5. This is too stressful. Expanding in this form is too stressful because the power is a power of 5. What about you have a power of 20 or a power of 10, a power of 30? Is this how you want to keep expanding? No. There is a way to go about it. And that way is what leads us to use what we call Pascal triangle. Now, Pascal triangle is introduced by a French mathematician who his name is called Blaise Pascal. So I'm going to walk you through on how you're going to come up with your Pascal triangle and how we can use Pascal triangle to expand this kind of terms. Now, when we say binomial, we call it binomial. Why? Because bi there simply means two. There are two terms in this expression. There are two terms here. So the next thing we do now, we're going to expand using binomial expansion using Pascal triangle. So I'm showing you now how I'm going to get in my Pascal triangle. I call the Pascal triangle. You can see, looking at this place now, I've constructed a Pascal triangle, and I'm going to show you how I did it. It is just this way. The first thing you do here is to drop one here. When you drop one, you write one, then you cover it with one. Cover it with one. Then the next thing you do is you add, sum this 1 plus 1 give you 2. That is the next step you do. The next thing you do, you cover it with 1 again. The next thing you do, you add this to 1 plus 2 give you 3. 2 plus 1 give you 3. You cover it with 1 again. 1 plus 3 give you 4. 3 plus 3 6. 3 plus 1 4. You cover it with 1 again. And next now you can also say 1 plus 4 5. 4 plus 6 is 10. 10 plus 4 is 6 plus 4 is 10. 4 plus 1 is 5. You cover it with 1. So the next thing you do, 1 plus 5 is what? 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. You cover it with 1. So you keep doing it this way till you get to any power you want. So this first one is a power of raised to the power of 0. That means when you are having such and you are having raised to power 0, this is when you use, this is what you get. So that's for that. This second one is the power of what? Raised to power 1, the power of 1. And this one is the power of 2. This one is the power of 3. This one is the power of 4. This one is the power of what? Of 5. And this one is the power of 6. So that is how it is. So if you look at it very well, you're going to see that we have constructed what I call a triangle. You can see, this is what we call a Pascal triangle. So from this place, you can also just come up and just meet it this way. Let me just help you out. You can do it this way. This is how we combine. This is how we combine. So that is for that. Now we are going to use this Pascal triangle to expand this. Now in using Pascal triangle to expand this, what you do is this. You will say, now I'm having raised to power of 5. So I'm going to look for the power of 5. Here is the power of 5. I'm going to use this one. I'll use for the power of 5. I'm going to use this. So to expand this now. Using the power of 5 to expand this, what do I get? So I'm going to say, from this place, I'm having x plus 5. So what I do, the first one here is 1. So I will drop 1 here, x, y, raised to power 5. And my y will be raised to power 0. Plus another one, the next figure, that is 5 x y, my x raised to power 4 and y raised to power 1 plus 10 plus 10 plus 10 x y, my x will be raised to power 3 and my y will be raised to power 2 plus the next one 10 x y, my y will be raised to power 2 and x will be raised to power 2 and y will be raised to power 3. So I move further, I say plus the next one 5 x y, x will be raised to power 1 and y will be raised to power 4. And lastly plus 1 x y, x will be raised to power 5 and y raised to power 0, and y will be raised to power 5. So this is just how you expand using Pascal triangle. This is just how you expand using Pascal triangle. I believe we are on the same page. So having done this, now the next thing you're going to do from here now, you're going to say anything raised to power 0 will give you 1. So I'm having 1 here. Is this sound as 1 here means if I multiply 1 by this x raised to power 5, what happens? It gives me x raised to power 5. Now you have to understand the particular logic in solving this. One thing about it is that when you look at it there, you notice that the power of x, as the power in x, the power of x is decreasing, the power of y is increasing. That is why we have 5, 4, 3, 2, 1, 0. And go to the y, 0, 1, 2, 3, 4, 5. So that is just how to solve it. So let's complete what we started. So we come down here and see 5 x is to power 5, x is to power 5, yes, plus 5x 4, so plus and lastly you have y raised to power 5. So this is just how to expand. Even though you are giving a bigger power, you're giving 20, you're giving 10, any power at all, in as much you apply this, I've just shown you Pascal triangle. This is the best way how to solve, to expand the power, a bigger power. Thank you very much for watching. I believe you really learned a lot in this lecture. If you really find this lecture helpful, why not like, follow us on Facebook and other social media, and also subscribe to our YouTube channel. The name of our YouTube channel is called DH Online Maths Tutorial. Thank you very much.